It is Wednesday. Database. Talked a little bit about indexes today. We did some more practice. A little more on normalization. And we have a project to work on Monday in class. So more on that. I'll have a handout in Canvas come Monday. Alright. Tech Den is Friday, 9 to noon. PC 229. Career Fair, April 4th. You can see who's there. Go to NIAC's website. There's also a little video. And this is really, we will get out of classes I have. We'll get out early in order to partake in the tech fair. That's a Wednesday. Alright. So, relational databases. You come up with this term, normalize the database. We talked about that the other day. When you have tables, you need to build relationships between the tables, right? So you have maybe a primary key here becomes a foreign key here, and you can build some type of constraint on that so that when you enter something here, it has to be here, as an example. When you build these tables, they have to be in a form that allows you to insert a new record, okay, and it doesn't cause the table to become inaccurate. You have to be able to delete a record. The table still, your database, the integrity of your database remains. That's a good way to put it. You have to be able to change. So what they've noticed when people created tables, this would create these anomalies that would create problems within the tables. So they created normalization, some methods that you can use to make sure this anomalies where you run into errors does not occur. So we did a little review. We talked about keys, primary keys. You can have a composite key, the key made up of multiple attributes. We talked about the primary key in a table, like student ID could be a primary key. Each one would be unique for the student. And then you can have other keys, like a candidate key. An example, we have a primary key of student, but we also could have email. Email would also work as a key, as a primary key in fact, because they're all unique also. And you're finding more and more places that gather data, identify people based on their email. Alright, dependencies. I'll go through a brief little example. Cookie cost, let's say you're buying cookies. Number of boxes times the cost, whatever that might be, say $3. Buy 5 boxes, $15 is the cost. So cookie cost is dependent upon the number of boxes. Dependencies. Another way to word that, the number of boxes will determine the cookie cost. Okay? A student ID will determine the other student attributes. If you pick this ID, you're going to get these attributes. They're dependent upon the ID. Alright. Side note, we did a little work in the database on work server 2. Okay, work server 2. We did a little work under this database, at least looked at some items. Okay, another example of normalization we talk about here. We have student IDs. Skiing is the activity. The fee is $200. If this student decides not to go skiing, we now lose that fee of $200. It's nowhere stored in our database. The fee is dependent upon the activity, not which student is doing it. Does that make sense? So this isn't normalized. At least not the second normal form. It's first normal form because we have an atomic value in each under each activity. So what can you do? Well, you're going to have to split this table. You're going to have activities and fees, and then students and activities. Alright. And you can build then the relationships. We did another one, student, dorm, fee. Now you could say, well, the fee is dependent upon the student based on which dorm they're in, but this is like a transient scenario. Even though this worked, but fee is actually dependent upon the dorm. So this should be split up. We should have student ID, dorm, then we could have dorm and fee. Fee is dependent upon which dorm, and then the student, what kind of relationship would that be? Probably a 1-to-1. Okay. Well, no. The student to one dorm, but the dorm to many students. Many to one. Many students live in the dorm. Alright. Next thing. In databases, they can create an index. You can create an index. What they do is they take a particular field and match it up, like let's say last name, and match it up with student ID. And they build a table. To search this table, you can search this table much quickly for a last name, Dirk. Once you have that student ID, then that can take you back to the base table and get you the record, rather than search the base table. So, tables and search. You can create an index. It's like an index in a book. You use the index to get you to the right page where you get your material. You can do the same thing in a database. And in some cases, they do it automatically. Alright. So we did a little work here. I gave an example. I put a link in the modules that go to a page that talks about foreign keys, primary keys, references, and relationships to other tables. And then I showed an example, a student example here. Create, table, rentals, and then we talked about this ID, reference the ID from the customer table. This must match the customer table. And then The same thing, they have another one here from the video table. Okay. Then I set an index on both of those. Name the index. And then I set a foreign key here, reference a customer here. So this is this one. This one is up in the customer table. Video, video. This one's here. This one's up in the video table. Alright. There's plenty of references out there that deal with this stuff. And I posted a couple in the modules. That's it for today.